ammonia लिखा है. Today we will do the basic gas that is in your syllabus, that is ammonia. Ammonia is the basic gas, the molecular formula NH3. And molecular mass is nitrogen is 14 plus 3, that is 17. Relative molecular mass is 17. Levy's dot cross structure, Levy's formula, you know that nitrogen has how many valence electron? 1, 2, 3, 4, 5, and hydrogen has 1. So 3 bonded pairs and 1 lone pair. That lone pair is very important. This lone pair is responsible for its basic character. Occurrence of the gas in free state, very small quantity of ammonia is present in air, and usually by the anaerobic decomposition of organic matter it is formed. One of the reactions that when you go around, means near the toilets especially, a very pungent smell, that is due to the decomposition of urea. This is urea, NH2CO, NH2, urea present in urine. So due to the bacterial decomposition of urea, ammonia is formed, and that is the reason why it stinks. Combined state salts of, these are all soluble salts, actually ammonium ions are all ammonium salts are soluble. So only in certain cases, like say sal ammoniac is the common name, ammonium chloride, etc., they are found on the earth's crust, and free state very by the decomposition of bacterial decomposition of organic matter. Forms of ammonia. The normal state is the gaseous form of ammonia, gaseous ammonia. Next is the liquid ammonia. Liquid ammonia means you have to bring it to the gaseous state. You know that gases, when pressure is applied and the temperature is lowered, then it converts into liquid. So under pressure, under high pressure, gaseous ammonia converts into liquid ammonia. That's how it is carried from one place to another. Okay, liquid ammonia. Then liquor ammonia. Liquor ammonia is a saturated solution, means ammonia dissolved in water, saturated solution of ammonia dissolved in water. That is called liquor ammonia. And liquor ammonia fortis, sometimes 0.888 also it is called. Now when liquor ammonia fortis is dissolved in water, diluted form of liquor ammonia is bench reagent that we use in the lab. Last time we were saying with for detection of cations, etc. It's a very important lab reagent. So liquor ammonia fortis is diluted and bench ammonia we procure. Now we come to the lab preparation. We come to the lab preparation of ammonia. How do we prepare in the lab? How do we prepare ammonia? So this is any ammonium salt. Any ammonium salt, when means an ammonium chloride, ammonium sulfate, any ammonium salt, when it is warmed with an alkali, then caustic alkali like NaOH, KOH or CaOH2, when warmed with a caustic alkali, it will form ammonia as one of the products. For example, suppose ammonium sulfate, NH4 whole 2 SO4. Ammonium salt treated with NaOH, caustic alkali, or KOH or CaOH2. What will it form? It will form Na2SO4. This will form Na2SO4. It will form ammonia, NH3, and it will form water. So this is Na2SO4, so 2, 2 and 2. Now it can be calcium hydroxide also, it can be any other salt instead of NH4 whole 2 SO4, NH4Cl. But of course we don't use, can be ammonium carbonate, ammonium chloride, ammonium sulfate, but not ammonium nitrate and ammonium nitrite. These two salts are not used. Why it is not used? Because they decompose and they form, see, ammonium nitrate, NH4, or first let me write nitrite, NH4NO2. This if you are taking, this salt nitrite if you are taking, then this itself decomposes into nitrogen and water. And ammonium nitrate NO3. This will decompose into nitrous oxide, N2O and H2O. So this is self-decomposer, so we don't use nitrite or nitrate. Apart from this, other salts can be used with caustic alkali. But in the lab method of preparation, we use ammonium chloride and ammonium chloride. What are the reactants? Ammonium chloride and calcium hydroxide, CaOH2. This ammonium chloride and calcium hydroxide reacts to give calcium chloride. Let's balance it. Calcium chloride plus H2O plus NH3, ammonia, which is liberated. So we balance this equation. 2 H2O and 2 NH3. So ammonium chloride with calcium hydroxide forms, it is warmed gently, not overheated, it is just warmed gently, and it gives calcium chloride, water and ammonia. So we can see that it is a moist gas over here that we are reacting. What are the reactants? Ammonium chloride and calcium hydroxide. Both are taken in this round bottom flask and warmed gently. The proportion is 2:3. This is 2 and this is 3. Proportion is 2:3. Ammonium chloride in less proportion, calcium hydroxide in more proportion. Why? Because ammonium chloride is sublime in nature. So check the rate of sublimation. To check the rate of sublimation, calcium hydroxide is taken in excess. That means 2 portions of this and 3 portions of calcium hydroxide. They are grounded together and mixed thoroughly first. Why are they grounded together? To give the maximum surface area and a close contact between the two substances. Now these two are together, heated over here, warmed gently. Another precaution, the round bottom flask has to be tilted because water vapor is one of the products. You can see that water vapor is one of the products. So water trickles down. As it reaches the cooler area, it trickles down and cracks the hot apparatus. So to avoid that, it is kept in an inclined position like this, the water vapor and the gas NH3. Both are gaseous. CaCl2 is solid, so it remains over here. And the other two products, that is H2O and NH3, these passes through this. And then it has to be dried. This is the drying tower. So what is used for drying? Calcium oxide. Why do we particularly use only calcium oxide? The reason is that ammonia is a basic gas and calcium oxide is also basic in nature. Metal oxide, so it is basic in nature. So a base does not react with another base. It does not react with calcium oxide and it is collected, the dry gas is collected by downward displacement of air. Now why it is those things we will do one by one. CaO. So let's see this. Reactants. What are the reactants? NH4Cl, CaOH2. What is the ratio of the reactant? This is 2:3. This is 3. And ratio is 2:3. Procedure. This now I told you the procedure. Ammonium chloride and CaOH2 in this proportion is grounded and mixed thoroughly, heated gently. And then the gases. What do we observe? That ammonia and H2O, the two gaseous products, pass through this delivery tube and enters the drying chamber. In the drying agent, what is the drying agent used in the drying chamber? It is calcium oxide. Why not the other? Because it reacts. The others like conc H2SO4, suppose. Ammonia plus H2SO4. Conc H2SO4 is another preferred reagent. So this is not preferred reagent. Why? Because this is an acid and this is a base. Acid base will react and form salt. It will form an H4 whole to SO4. This will form an H4 whole to SO4, ammonium sulfate will be formed. With P2O5, it will form ammonium phosphate, and with CaCl2, this is 2NH3, CnH4 whole 2 SO4, so 2NH3 plus H2SO4, NH4 whole 2 SO4, NH3 and CaCl2 gives an addition product, CaCl2 dot 4 NH3. Some books you will find it is written 8 NH3. So 8 NH3 is also correct, both are correct. So this is an addition product, CaCl2 dot 4 NH3. Then if you are using P2O5, we'll rub this out. Precaution, I'll write late. NH3 plus P2O5 plus this gives NH4 whole 3 PO4. Okay, so NH4 whole 3 PO4. This we take as 6, 2, 3, then it is balanced. So ammonium phosphate will be formed with P2O5, sulfuric acid, it will form ammonium sulfate, and with calcium chloride it will form a addition product. So these three are not taken as drying agent. What is used as a drying agent then? Another base, that is quicklime, CaO. Slaked lime, this is called slaked lime, calcium hydroxide. Slaked lime is used for preparation and quicklime is used for drying ammonia. Now collection, after that, okay, so one step was precaution. What was the precautions taken then? Drying agent we are taking as CaO. And what are the precautions? Should be inclined. Then the drying agent should be gently warmed, and the drying agent has to be calcium oxide, another base, and it is collected. Now collection, okay, collection by downward displacement of air. Vapor density of ammonia is only 8.5, whereas air is 14.4. It is much lighter than air. So because it is lighter than air, it is collected by downward displacement of air. This ammonia is collected here and the air is displaced. And it is not collected over water because it is highly soluble in water. 702 parts dissolves in 1 part of water. So it is not collected over water. It is collected by downward displacement of air. Now identification, how will you know that this gas jar has become full of ammonia? It is tested by a rod dipped in HCl. If you bring a rod dipped in conch HCl over here, then it will start giving dense white fumes of ammonium chloride. You will see dense white fumes. That means this jar has become full of ammonia now.